Alright, we're on number 38. We're given Q, R, and S, and let's see, I ended up graphing Q, R, and S, Q, R, and S on a graph, so to make sure that's what you should do as well. The 3 points, I just plotted the 3 points, and then we're asked to find if it's a right triangle. First thing I did, I graphed the points. I think this is my right triangle, but we're not sure. We need to prove it. I found the distance from Q to S. Use that formula if you need to. You've already had it in questions 1 through 7, but it's x1 minus x2 squared plus y1 minus y2 squared. Do the square root of all that. I ended up doing it. I got from Q to S was 8.5 with the square root of 73. Q to R, same thing, 8.5 with the square root of 73. And R to S here being 12.1. Remember, once you're done here, we have a right angle, so we'll do the Pythagorean theorem. 8.5 squared plus 8.5 squared should equal 12.1 squared. And if that is true, then it is a right triangle. In that situation, it is true. We got 2 answers here with no, 2 answers with no, and 2 with yes. Go through and you see everything except for these last. Both of these are exactly the same until you get down here at the end. Make sure you know that it has to be R to S here at the end has to be the longest side of 12.1. Alright, on number 35, determining whether something is a right triangle or not. Remember, if it's a right triangle, okay, we're just going to do 1 squared plus the next number squared equals the third largest number squared. I have it there. Yes, it ends up working out. Remember, a Pythagorean triple is nothing but a right triangle with no decimals. Since we have no decimals there, and this ends up working out as a right triangle, we got yes and yes. On number 40, the length of a diagonal of a square. I got that square here. Let's see, it's a little hard to see. Let's see if we can get it zoomed in there for you. Before I get there, it's the length of the diagonal is 24 square roots of 2. Find the perimeter. Let's see if we can get all there. Alright, there we go. 24 square roots of 2. Trying to find the perimeter of all these. I do have a right triangle because it's a square. I can do x squared plus x squared equals this, Pythagorean theorem. I have x squared plus x squared equals that 24 square roots of 2 squared. After I did that, don't forget your parentheses in the calculator, square it. You get 1,152. Remember, if you're adding these two together, it just simply becomes 2x squared. Divide by 2, getting these two x's off here, crossing those out. Divide by 2. I still have x squared. To get rid of that squared, I got to do the square root of both sides. Do square root of 576. I get 24. After I get that 24 there, remember we're finding the perimeter, so all these are 24, 24, 24, and 24. So I just multiplied it by 4 and got 96. Zooming back out, that ends up being 96, which is C. Alright, looking at, we're now on too much stuff. Let's see, moving on up. Alright, find x and y here. X is that degree there, it's kind of hard to see. Y is that middle length from there to there. All these are the same, making a square, making the corners 90 degrees. Obviously, for a square, and this is going to be 90 degrees here. If it's a square, it cuts it in half, making it 45 there or there. You can go ahead and eliminate these two. They're not 45. And then it tells you this one's 13.1. Then you know this is 13.1. Hey, Pythagorean theorem again. 13.1 squared, 13.1 squared equals that diagonal squared. I have it there. Ends up being that decimal, which is 13.1 times the square root of 2. Alright, back to it. We're trying to find y. 60 degrees, we used the O and we used the H here. O and H ends up being the sine, O and H, and it's O over H. So O is the y, so I put y. The H is 24, got here. Sine is 60 degrees. Don't forget that's the one we're going from. Okay, we know that's 30, but we're always going from this angle. That's how I label my O, H, and A. Once I got this in, hey, look, it's on bottom again. 24 is on bottom. Multiply both sides by 24. Puts it out front. 24 times the sine of 60 degrees ends up being 20.8. After you saw it wasn't y, you wanted to check, make sure it was 12.3. And 12 square root of 3 is the same thing as 20.8. Alright. Alright, moving on to question 43. We're in Chicago. You knew I had to draw a great and wonderful picture for this one. We're in Chicago. A tower's this tall. Here's the degree from the building, from his feet to the building. How far are we? See if I can get my picture up here. So we got his feet, we got the tower, 1450. We're looking how far it is from here to here. Okay, we're given that angle there from his feet to the tower. Remember, that's called the angle of elevation. So from here we got A and O because it's beside it, and opposite. Which one's A and O? That's the tangent. So I said the tangent of 17.5 equals the opposite over the adjacent. Don't forget that's tangent. If you need to go back, right sine, cosine, and tangent. Old hoes always have odd aces. You can do that as well. Once I got here, X is on bottom. Remember, when X is on bottom, I just simply switch the X with the tangent of 15.7. So I wrote X on the left, tangent of 15.7. Typed it in, hit it in my calculator. I got 5,158.5. Hint, don't forget your radian mode again there. So 5,158.5. And let's look back at our original. There we go, 5,159 if we rounded up. So none of them are really. This one was a little closer, but not as bad. Alright, 44. 44, a landscaper has a retaining wall store up a side of a hill. To ensure against collapse, the wall should make an angle of 75 degrees or less from the ground. If the wall is 25 feet, what is the height of the hill? You know, I drew me a great old picture for that one too. We got our hill. Here's my wall. What they don't tell you, and I'm sure they'll tell you on the exam, is that the wall is actually the height of the hill. So we know that wall is 25 feet. The hill created that 75 degree angle there. I just kind of take it and drew an actual triangle that you're used to seeing out here for the same thing, 75 degrees and 25 feet. From this angle we got the opposite and hypotenuse, and that is sine. So sine of 75 equals, remember O's on top, so X over 25. When X is on top, multiply both sides by 25. When you do that, it ends up just moving it out front. 25 times the sine of 75 degrees equals X. Ended up being 24.1. We go back to our original picture. We got 24.1. Don't forget, if I'm going too fast, pause, rewind, do all that kind of good stuff. Alright, looking at 45, two cabins are sitting, are observed by a ranger 60 feet and 60 feet above the park. Elevation of 11.6 and 9.4. How far are the cabins apart? Of course I got a picture. Y'all know I do. Alright, so we got our two cabins. Here and here, cabin 1, cabin 2. Let's use a different color. We're wearing that color out. Cabin 1 and cabin 2. The ranger, remember, he doesn't move. He sees cabin 1 and cabin 2. they're both 60 feet. So from there to there and there to there, both 60 feet. One of them is 11.6, one of them 9.4. I kind of drew it over here again, 11.6, 60, 9.4 and 60. Call one of them X and one of them Y because we have to find both of them. Once I find both of them, obviously this one will be X from here to here, and the Y, which would be from his site all the way over there. And if I can just subtract the two, I end up with the answer. Finding X, hey, we got opposite and adjacent, that's the tangent. With the opposite on top, over X, X is on top, or I'm sorry, X is on the bottom, so I just switch them. Switch the X with tangent of 11.6. So we got 60 over tangent of 11.6. Ends up being 292.3. Alright, I'm going to have to move it here, so hopefully you won't get too lost. Alright, we got the tangent of 9.4, opposite of 60 over Y. Remember, that's opposite over adjacent. If you got opposite over adjacent here. End up switching these two, getting 60 over tangent of 9.4. Put that in your calculator, end up getting 362.4. Now remember, I need to subtract the distance of the big one minus the small one to figure out how far they are apart. So I end up subtracting the 362.4 minus the 292.3 and end up getting 70.1. We go back, look at our answer key. Look, 70.1. How great did that work out? Alright, number 46. Find the measure of each interior angle. So we're talking about one interior angle of a regular. Remember what regular means? All the sides are the same. A pentagon meaning 5 sides. So don't forget your vocabulary. Interior angle, one interior angle. A regular pentagon. Round to the nearest tenth if necessary. Alright, don't forget that magic formula. S equals 180 n minus 2. That's going to tell us, remember, the S is the sum of all the angles. The n is the number of sides, which in this situation is 5. I think I even got 5 written there. So plug my 5 in, found out all the angles, or the sum ended up being that 540. Remember, that's all the angles on the inside. If we drew a quick pentagon, it's an ugly pentagon, but just imagine that all the sides are the same. The total of all the insides is 540. We want to know what one interior angle is. So I divided that by 5. Ended up being 108 for one interior angle. That's what it ends up being.